All right, you guys, so we're going to go over today how to tell what like the maximum height of something is from a graph, a table, and an equation. So from the graph itself, it's actually pretty easy. Obviously, you just kind of look at what the highest point is. So this one says the flight of a football kicked by a high school senior at the start of a game is modeled by this graph. X is the time the ball is in the air in seconds. Okay, so this down here, this is time in seconds, and then it says the y, the f of x, is the height. So this is the height of the ball. Okay, so so you can see that, you know, the highest his ball goes is up here. I mean, like literally you can physically see that, right? And that's going to be over here, which is at 16. So I'm going to assume this is feet. So it doesn't say, but let's assume this is feet. So the highest it goes is 16 feet, right? And it hits 16 feet. If you kind of look down, that was supposed to be a straight line, but it hits 16 feet right there at 4 seconds. So at 4 seconds, it hits 16 feet, and that's the highest it goes. And then you can see it kind of goes off the ground, and then it comes back and hits the ground right here. And that would be at 5, 6, 7, 8 seconds. It hits the ground again, right? Okay, and you can kind of see the same thing in the chart. The chart is pretty easy as well. Obviously, to find the highest, you're just going to look at the y value, and the y value that's the highest is this. So that's the highest amount of feet it goes, is 12 feet in the air, and that this time is at 3 seconds. And then you can see that it hits back at the ground at 0 is when it hits back at the ground at 6 seconds, okay? So those two are pretty easy because you can actually see it. The last part is the equation. So the equation isn't really that much harder, but you just need to know how to find the maximum and at what time. So the way that you find at what time the maximum is going to hit is you use this little equation. You do x equals negative b over 2a. Okay, and that's going to give you the x value of the maximum. Okay, so this gives you x value of the max. Okay, so if we do that for this one, and a, b, and c are the same thing as like if you were using quadratic formula, right? A is the number in front, b is the number in the middle, and c is the number in the back. So if we did that for this one, negative b, that would be negative 8, right? B is 8 over 2 times a is negative 1, right? Because a is just, this is a, this is b, right? So that would be what, negative 8 over negative 2, which is a 4. So at 4 seconds, that's when it hits its maximum. And then the way that you find the maximum, okay, so then find max by plugging the x value in. Okay, so you'll just plug this in to the equation. Okay, so we'll do g of 4 equals negative times 4 squared plus 8 times 4 plus 9. So you're just putting that into the calculator. Okay, so I'm walking to go get my calculator. But you just put that in, right? So negative 4 squared plus 8 times 4 plus 9. And that's 25. So that is the maximum. So that's the maximum that it goes. Okay? So now that we know how to find it from each one, let's go and read this. It says whose ball was in the air the longest, whose ball was in the air longer. So this guy's was in the air for 8 seconds before it hit the ground. This guy's was 6 seconds before it hit the ground. And then this last one, we didn't actually find it, but if we think about it, the maximum is halfway, right? So this is the max here. Let me write it. The max is 425. This is the max point. That's halfway. So if it's 4 seconds, and you can even kind of draw it, right? So that was ugly. Hold on. Let me use black, actually. Okay, so if I draw this, The maximum here would be at 4, and then we'd be up here at 25, right? And so that's halfway. So that means it hits the ground at 8 seconds because it needs another 4 seconds, right? So whose ball was in the air longer? The first two guys were the same. So the graph and equation are in air same amount of time. Okay, whose ball was kicked the highest? Well, this graph was 16 feet was the highest. This was 25 feet, and the other one was 12 feet. So obviously the equation was the highest, right? The equation was kicked the highest. And at what time did each reach its maximum height? So the graph and the equation reached their maximum height at 4 seconds, right? They were both 4 seconds, I believe. Let me go look. Yep, this was at 4 seconds, and then that one over there was also at 4 seconds, and then this one was at 3 seconds. So the table was at 3 seconds. Okay? So that is really all your lesson today. So hopefully that made sense. The hardest part is just doing the negative b over 2a and then plugging that x value in to find the maximum height.